Alright guys, so go ahead and start copying this down. Today's notes cover working with absolute value as an equation, as well as a review of linear inequalities. And the reason we're doing these two different things, which seem disconnected, is because we're going to need to have both of them in order to solve absolute value inequalities, which we're going to start on Monday. Okay? So today we're going to talk about absolute value equations, and then in a little while we'll talk about linear inequalities. Everyone should remember that absolute value is the distance from 0 on a number line. Okay? So you can walk to the right, you can walk to the left, but no matter which way you walk, you're still going to be calculating the distance from 0. What do we know about distance, or what do we know about absolute value? What kind of answers are we going to get? Yeah, so absolute value is always going to be positive. So an important thing to keep in mind as we go through these problems and as we start on inequalities next week. Okay, so if I were to ask you to solve the absolute value of x equals 2. If we picture this on a number line, how many different values are there that have a distance from 0 of 2? 2. What are those? All right, so -2 is a solution, and 2 is a solution. Everyone understand why both of these are solutions? Mm-hmm. Doesn't matter if you walk right or left, they both have an absolute value of 2. Okay? So the way I would translate this into solving an equation is I would take this absolute value of x equals 2 and I would split it up into 2 pieces. What I would do is I would say, okay, well, I know then that the inside of my absolute value has to be equal to +2 or -2. So I write 2 little equations, the inside equal to +2 and the inside equal to -2. These are already solved for us because this is a trivial, really simple example just for us to see what's happening. But to write my final answer, I'm going to put my final answer in curly brackets with the smaller number first. Why do I use curly brackets?
Because it's not everything in between.
Yeah, it's not everything in between. It's just this value, -2, and +2. It's not everything in between those two values. So the curly brackets represent any finite list of numbers. Anytime you just want to list specific values. Yes, ma'am?
Wait, why does it say always positive if the answer is -2 as well?
Okay, because the solution, what's on the other side of the equal sign, is always positive. You can take the absolute value of any number, but the answer you are going to get when you take the absolute value, that's what's positive. Does that make sense? Okay. All right, so here are your steps for solving an absolute value equation. The most important step, circle it, highlight it, star it. Before you do anything else, you must isolate the absolute value. It is so, so important. What does it mean when I say to isolate the absolute value? To get just the absolute value alone on one side. Everything else that has been added or multiplied to it has to be on the other side. Okay? That is so important. It's one of the easiest ways to mess up. You must isolate the absolute value every single time. Okay, the next step is to set up your 2 equations. You will set the inside equal to the positive value and set the inside equal to the negative value. Then you will solve for each x and put your final answer into curly brackets. Okay? Yes?
Is like the official name for the curly brackets?
I think the official name for curly brackets is braces. But, like, I think it's a brace. But I don't know for sure. Good question. Okay, let's look at number 1. What's my first step? Isolate the absolute value, and how am I going to do that? So I'm going to get that the absolute value of negative 3 plus x is equal to 12. So that means that the inside is either equal to positive 12 or negative 12. So I'm going to set up my 2 different equations. Yes, this is isolating the absolute value. Nothing can be added or subtracted from it or multiplied by it. So I'm going to say negative 3x equals 12 and negative 3 plus x equals negative 12. I set the inside equal to the positive value and the inside equal to the negative value. Questions on that step? Okay. What's your question?
My question? I don't understand why you split it into equaling to 12 and negative 12.
Okay, the reason that you split it into 2 equations is because the inside, in order to have an absolute value of 12, the inside either has to be equal to positive 12 or it has to be equal to negative 12. Okay? Go ahead and solve each of these equations. What do I get here? What do I get here? Okay, x equals 15 and x equals negative 9. Let's check our answers. So we're going to take our value and plug it back in to your original equation. Okay, so negative 3 plus 15, 12, the absolute value of 12. 12 minus 2 is 10. Okay, let's try negative 9. Negative 3 plus negative 9. Negative 12, absolute value of negative 12. 12 and 12 minus 2, 10. So these are each our answers. Curly brackets. Smaller number first.
It's always a smaller number first.
Yes, smallest number goes first.
Will there ever be like an infinity as an answer?
There's no way that infinity could be a solution to an equation.
Like there's just absolute value of x equals infinity.
But that's not true. Like, that can't be right.
Oh yeah, because that's one of the
Okay? All right, let's look at number 2. We have to isolate this absolute value first. When you have both multiplication and addition or subtraction going on, you have to go in reverse PEMDAS order in order to isolate this. Okay? Reverse PEMDAS, meaning you always add or subtract first, then multiply or divide. Okay? So the correct process to isolate this is to start by adding 6. Okay, what would I do next? So I get the absolute value of x over 4 is equal to 1. From here, what do I do? Split it. So I get x over 4 equals 1, and x over 4 equals negative 1. So what does x equal? Good. Okay, and I write my final answer. Oh, yep, let's check. Guys, hush. So if we go ahead and check, I'm going to plug in 4 for divided by 4 is 1. What's the absolute value of 1?
1
Times 2?
2
Minus 6?
-4.
4. Check -4. We get -1. The absolute value of -1 is 1. Times 2 is 2. Minus 6, -4.
When you're working with multiplication or division, will it always make it where like the answers will always be opposite of each other?
I don't like to say always or never in cases like that because weird things end up happening depending on if you're dividing by 1 or whatever might be happening. So I think that might be a fair assumption, but I wouldn't generalize to that point. Okay, please try number 3 on your own. I'm trying to understand that I can still hear them when I come inside, so when they talk badly about me once I leave, doesn't make me so happy. Okay, Lindsay, what'd you do first? Okay, yeah, and dividing by half is the same as multiplying by 2. So we would get absolute value of 4 minus 3x equals 12. Great. Rosie, can you tell me what you did next?
I subtracted 4.
Did you write anything down next?
I split the equation.
Good. Can you tell me what the 2 equations you got were?
4 minus 3x equals 12, and 4 minus 3x equals 12.
Awesome. Okay. Ryan, you have a question, or you want to continue? Okay. Can you tell me what the solution is for the side that's equal to positive 12?
-8/3.
Okay. And Dorian, what did you get for the solution for the side of equal to negative 12?
16/3.
Very good.
What?
It's 16/3.
Mm-hmm.
Wait, I got the opposite.
Well, see if you wrote it opposite.
No, check first. It's -16/3, isn't it?
No, it's not.
Oh,
When you subtract 4, you're going to get negative 16 equals negative 3x. Divide both sides by negative 3. It's positive. All right? You will go back and check your values. Okay? You will find out that they were true. Okay, the answer you get after applying the absolute value can't be negative, but you are allowed to take the absolute value of a negative number. So this isn't my answer. I'm not saying that an absolute value is equal to negative 8/3. I'm saying that x is equal to that. So when I plug that in, I'm allowed to take the absolute value of a negative. I just can't have my answer over here be negative. Okay? So that's a good lead-in. Let's look at number 4. What's the first thing we would do on number 4? Divide by negative 3.
Is that a 21?
Yep.
Okay. Oh. I thought they were going to divide. Oh,
So 21 divided by negative 3. Negative 7. Do we go any further? No, why not? Okay, but I'm saying, do I start and separate my equations and stuff? No, I can't. Why not? Yeah, this absolute value is equal to a negative number. Can absolute value ever be equal to a negative? No. So there is no solution here. You can write no solution, or you can write a 0 with a slash through it, but it is not undefined. It just doesn't exist. There's no solution. Okay, and this is because the absolute value must be equal to a positive number. Okay?
Is it okay if it's equal to 0?
Yep. Can be equal to 0, because we know the absolute value of 0 is 0. Okay, so now we're going to review some linear inequalities. So let's start off with 3x minus 8 is less than 10. Yep, I would start by adding 8. So I get 3x is less than 18. Then what? Divide by 3, so I get x is less than 6. Okay, that is your answer as an inequality. How would I write my answer as an interval?
X, that.
Negative infinity 6, both in parentheses.
Good. That's your answer as an interval. You're going to be asked for answers either way. Okay? You need to be prepared to write it as an interval or as an inequality. Your homework, just 1 second, Reese. Your homework is also going to ask you to graph this. And when it says to graph it, okay, you're going to plot your 0 and your 6 on a number line. We're going to circle is around 6.
Open.
Open, and which way do we shade? Left. So when your homework says to graph, solve and graph, this is what it's asking for. Question, Reese?
When do you switch the inequality? Like, when you transuse the symbol?
We're going to see that in number 6. Okay? So let's go ahead and solve number 6. What am I going to do first? Subtract 2. So I'm going to get negative 9x is greater than or equal to 15. Then what am I going to do? Divide by negative 9, which causes what to happen? Yeah, your sign is going to flip. When does your sign flip? Good. When you multiply or divide by a negative, you've got to flip your sign. All right, simplify our answer, and what will we get? No, that can be simplified. Good. That's our answer as an inequality. What's our answer as an interval?
Negative 5/3. Negative infinity, comma, 5/3 bracket.
Good. All right, and go ahead and graph that on number line. What kind of circle? Shade which way? Good job. Okay, now we're going to talk about two very small but very important words. Or and and. Okay? Or, when you're dealing with inequalities, or represents a disjunction or a union. Or represents a disjunction or a union. Okay? And your answer is the union of shaded regions. And that's going to make a lot more sense once we try an example. So for now, I'll just go ahead and write down the answer is the union of the shaded regions. All right, so number 7 says 2x minus 3 is greater, 2x minus 1 is greater than 3, and x minus 2 is less than or equal to negative 7. So let's go ahead and solve each of these inequalities. So starting with the left one, what would I do? Add 1. So I get 2x is greater than 4, and x is what? Greater than 2. All right, and let's solve our other one. What do I get when I have x minus 2 is less than or equal to negative 7? Good, and I have my or here. We've got to plot this on a number line and see what happens.
Whenever it's ors, are they always going to be like opposite direction the inequalities? Okay.
Okay, so let's start by graphing x greater than 2. Open or closed?
Open.
Shade which way?
Right.
All right, let's graph x less than or equal to negative 5. Open or closed? Shade which way?
Wait, so you did say they'll always be going in opposite directions? Oh, no, they won't.
Okay, so what I wrote up here is the answer is the union of the shaded regions. So the solution on number 7 is anywhere on the number line that has pink or green. Okay? So it's this whole part that has pink and this whole part that has green. So the way you would write that as an inequality is the way when we solved it. That's how your answer will look if you're asked to write it as an inequality. If you're asked to write it as an interval, what are you going to need to use? Yeah, and what does that U represent? Union. So let's go ahead and write this using an interval. Negative infinity
Negative 5.
to negative 5 with a bracket. Union. Good. Those are the two different ways to write that answer.
And the union is the interval, right?
The union represents
Like,
the
no,
union
like,
of the two intervals.
The union interval equation is.
Yes, sorry. This one with the union is interval notation. This is inequality notation.
Will we ever provide you with the second notation?
No.
That's strong.
Okay, let's look at number 8. 2x minus 1 is greater than 3, or x plus 1 is less than or equal to 6. So I'm going to go ahead and solve each side. So you should get x is greater than 2 or x is less than or equal to 5. All right. You cannot just assume that what you have written down is your solution. You've got to plot it on a number line, double check. Okay, so let's plot the pink one first. X greater than 2. What am I going to have at 2? Open, shade which way? Okay, what happens at 5? Goes to the left. Okay, what do you notice? They overlap, and everything ends up being shaded, right? Every single value on our number line is either going to have pink on it or green. So if every single value has either pink or green, then the solution to this inequality is all real numbers. If you're asked to write all real numbers in interval notation, it's negative infinity to infinity. If you need to write all real numbers in inequality notation, it's your double backed R.
So if you wrote it like you said double backed R and then double backed R.
Is there a question?
So if I wrote like X is greater than 2, or is he wrong?
If you write this step, you haven't generalized your solution. You haven't like made that jump to understanding that means it's all real numbers. So you would lose quite a bit of credit there. Okay, next let's talk about and. Where or was a disjunction, and is going to be conjunction. And instead of representing a union, it's going to represent the intersection. So your answer to an and problem is the where your shaded regions overlap, or the intersection of your shaded regions. Okay. So look at number 9. We have 2x minus 6 is greater than or equal to negative 4, and 2x minus 6 is less than or equal to 12. All right, so we're going to go ahead and solve. Add 6 to both sides, and I get 2x is greater than or equal to 2. Then what? All right, so x greater than or equal to 1. Now let's work the other one. 2x minus 6 is less than or equal to 12. So 2x is less than or equal to 18. X is
9.
less than or equal to 9. All right, let's go ahead and plot this on a number line. What happens at 1?
There's a closed circle.
Okay, closed circle. Goes to the right. All right, what happens at 9?
Closed circle.
Closed circle. You go to the left. Okay. I told you the answer is where the shaded regions overlap. So where or was it had to be green or red. With and, green or pink. With and, the solution has to be green and pink. So what portion of the number line has green and pink on it? Between 1 and 9. Are 1 and 9 included? Yes, because it's a closed circle and then the shading overlaps. Now, if one of these was an open circle, say there was an open circle at 1, would 1 be included in your solution? No, because it would just be that other color. Okay? Your solutions to an and have to be solutions to both inequalities. So as an interval, how would I write this? Good.
So if it was
Sorry, go ahead.
so if it wasn't like so if it was just less than or greater than, it'd be a parenthesis.
As an inequality, how would I write this?
1 is less than or equal
greater
to.
than or equal to X.
1 is less than or equal to x, which is less than or equal to 9.
That's inequality.
Mm-hmm.
And the other one's interval.
This one's an inequality. This one's an interval. Now, you might see it written like this, with the and. Or you might see it written as, notice that the 2x minus 6's are the same. Do you see that? So you could also see this written as negative 4 is less than or equal to 2x minus 6, which is less than or equal to 12. These mean the same thing. Okay? You just need to know that you can be signified to use and when the and is written, or if it's written as one compound inequality. Both of these things mean and. But if you want to separate them and write them as two inequalities, that's fine. Okay? So look at number 10. 10 is less than or equal to x plus 2, which is less than or equal to negative 3. With a compound inequality, this implies and. Okay? And just like up here, whatever I do to one side, I have to do to the other. Well, with a compound, whatever I do to one part, I have to do to all three parts. So here, to isolate x, what am I going to do? Subtract 2 everywhere.
Could you just split it up?
All right, so 10 minus 2 is 8, is less than or equal to x, which is less than or equal to negative 5. Okay, so let's put this on a number line and check what we have.
Will it ever be different? Like, will it ever be wrong?
Hopefully some of you are already seeing a red flag here.
Yeah.
Okay, I'm going to graph my 8 is less than or equal to x in pink, and I'm going to graph my x is less than or equal to negative 5 in green. So, I'm going to graph here's 0. Here's my 8. What kind of circle do I have at 8? Which way am I going to shade? Okay, what kind of circle am I going to have at negative 5? Which way am I going to shade? Okay, now and means where the shading overlaps. Well, what's the problem here? They don't overlap. So my answer is no solution.
How do you know the shade to the right?
Because 8 is less than or equal to x, which is the same as saying x is greater than or equal to 8.
Okay.
You can read it forwards or backwards. You can write no solution this way or this way. Now, you have to, if you stop here and you give me this as your answer, you're going to lose almost all the credit. I might give you 1 point for subtracting 2. You have not understood what that means if you just leave that as the answer. You have to either understand from the inequality form or from plotting it on a number line. But you've got to make this jump that it is not possible for a number to be bigger than 8, but less than negative 5. It's just not possible for that to happen. Okay? You can stop here and notice it and write your answer as no solution. But you've got to make that jump that this is not no solution. Okay? Does that answer whoever had a question over here? Okay. All right, one more problem. If A is less than 0 and B is less than 0, I want to find AB. What does AB mean?
The distance between it.
A times B. Okay? All right. So I have the absolute value of A plus 4 equals 7, and I've got the absolute value of B minus 6 equals 12. What do you think is a good way to start solving this problem? Yeah, just go ahead and solve for A and solve for B, right? So in order to solve for A, I've got to write this as 2 equations. What are those 2 equations?
A plus 4 equals 7, and A plus 4 equals negative 7.
Good. A equals 3, and A equals what? Negative 11. So based on our constraints, which one do I want to use?
The negative.
Yeah, because it says A is less than 0. So I don't want this one. I want to just keep this one. All right, let's solve for B. What are the two equations I write? All right, add 6, so I get B equals 18. And I get B equals negative 6. Which one do I want? Negative 6. All right, to get AB, what am I going to do? Multiply them together. So negative 11 times negative 6 is what? 66. Matthew, what was your question?
Sorry.
That's okay.
Will there always be just one positive answer and one negative answer?
In a problem like this, if they wanted you to do this, they would have to give you constraints that would only leave you one answer. Okay? All right, please make note that there have been a few revisions to your homework. We took out numbers 16, 17, and 32. Okay? And switched 53 for 49. So we took out 16, 17, and 32, and we swapped 53 for 49.
And the page number 29.
What were the three numbers you just switched out?
16, 17,